Dear students, in this video we will cover the chemistry of class 10th. हम कुछ इंपॉर्टेंट टॉपिक्स यहाँ कवर करेंगे जो कि आपके बोर्ड एग्जाम में हेल्प करने वाले हैं. So let us start with chemical reaction. A chemical reaction is the graphical representation of the symbols of the atoms or the elements. Reactants combines to form products. Reactants in the left hand side and products on the right hand side. Any chemical reaction follows the law of conservation of mass. Must remember this point. Law of conservation of mass. What is the law of conservation of mass? Total mass of the reactant should be equal to the total number of products or the mass of the products. Next point is the changes carried out during a chemical reaction. The first one is a change in color. Second is a change in state. Next is a change in temperature during the chemical reaction. And then evolution of heat. Maybe half marks. This point will cover a 2 marks question. So must remember these 4 points. Change in color takes place, change in the state like physical state, solid, liquid, gas. And temperature change during the chemical reaction, and then evolution of heat. On the basis of evolution of heat, reactions are of 2 types. First is the exothermic reaction, in which evolution of heat takes place. Point to remember here, you can cite the example of combination reaction. Carbon plus oxygen gives carbon dioxide. Here the combination of the 2 substances gives a single product. So this is a chemical reaction, or the type of chemical reaction is combination reaction. Where combination takes place, there is the evolution of heat. So the exothermic reaction can be a combination reaction. In another way, if we talk about the endothermic reaction. What are the endothermic reaction? Endothermic reaction in which the supply of heat or absorption of heat takes place. Absorption of heat takes place in the reactions where decomposition takes place. Decomposition of calcium carbonate gives calcium oxide plus carbon dioxide. Calcium oxide is a quicklime. Must remember the name of this compound, quicklime. This is a carbon dioxide gas. This is the example of decomposition, and decomposition requires the absorption of heat. So this is the endothermic reaction. Endo means heat is entered into the reaction mixture to split the complex compound into the simpler ones. One more point from this concept is endothermic is related to the decomposition, and decomposition is further of 3 types. Decomposition is further 3 types. First one is the thermal decomposition, as we cited the example. This is the absorption of heat or the supply of heat. Heat is related to the thermal. So this is the example of thermal decomposition. Thermal decomposition, calcium carbonate. Second one is photolytic, and next one is electrolytic. Thermal decomposition where heat is required, photolytic where light is required, and electrolytic where electricity is required. So decomposition can be possible by supplying heat, light, and electricity. Example of electrical decomposition is H2O. By passing electricity, it will be changes into H2 plus O2 on the respective electrodes. There is a deposition of hydrogen and oxygen gas takes place. If we talk about the photolytic decomposition, it means the presence of sunlight. So AgCl is a silver chloride. Initially it is white in color. In the presence of sunlight, it will be changes into silver plus chlorine gas, and it will turns into gray. This question will be asked with respect to the color. So must remember the color of the substances. AgCl is white in color, and after breakdown of this AgCl in the presence of sunlight, it will be changes into gray. In same way, AgBr will be split into Ag plus Br2. But this question will be asked as, name the reaction, write the reaction which is used in black and white photography. Okay, black and white photography. The point to remember here is the black and white photography. One of the important question to be asked here is the black and white photography. So this is the type of decomposition. Hope so you will understand the concept of decomposition and types of decomposition along with combination, exothermic and endothermic reaction. Now, if a more reactive substance will displaces the less reactive substance, there will be the displacement or the substitution. Substitution is somewhat the advanced form that will be discussed in chapter 4 of the carbon compounds. Suppose you have copper sulfate plus zinc, it will give zinc sulfate plus copper. But you must have to check the reactivity series. कटरीना ने कार मांगी आल्टो जेन फरारी, फिर भी हाई क्यों मिली सिल्वर ओडी. So you must remember the trick to identify the more reactive metals to be displaced by less reactive metals to be displaced by more reactive metals. So must check the element or the substance that is to be displaced in the displacement reaction. एक single concept आपको displacement reaction में याद रखना है. Next reaction is the double displacement. डबल डिस्प्लेसमेंट रिएक्शन से आपके ऑलमोस्ट 3 क्वेश्चंस कवर इजीली हो जाते हैं. सो द फर्स्ट वन इज द डबल डिस्प्लेसमेंट एंड न्यूट्रलाइजेशन एंड प्रेसिपिटेशन, एंड द नेक्स्ट वन इज प्रेसिपिटेशन. If simply acid and base is there, then salt and water is formed. That will goes to neutralization and double displacement also. But if a white insoluble substance is formed, that will be represented by the down-headed arrow. It means that this is the insoluble substance that is white in color. If you will be asked a yellow colored PPT, then it will be PbI2. lead iodide. So how will you prepare these substances or precipitate during the chemical reaction or the precipitation reaction? So simply we can consider BaSO4. This BaSO4 is taken with the help of BaCl2 and Na2SO4, sodium sulfate. So simply there is a double displacement BaSO4, so NaCl, so 2 NaCl is there. This will be our precipitation reaction. Simple. So must remember this equation. This is very important. Next point is corrosion and rancidity. Corrosion, gradual eating of the metal in the presence of air and moisture. Must remember the examples. If iron get corroded, it is called rust. Black coating on silver, green coating on gold, Au is gold. Okay. Now the question, rancidity. Rancidity is the oxidation of food in high temperature. How to prevent the substances or the food from oxidation? We have to use antioxidant. Antioxidants, any examples of antioxidant? That is sodium benzoate, food preservative. We can use this compound as food preservative. Next is the nitrogen gas in packaging of chips and some other snacks to prevent it from getting oxidation. Next point is oxidation and reduction. Oxidation is the addition of oxygen, like MgO2 gives MgO, and the same reaction gives another question. What will be the reaction question? The substance which burns with dazzling flame. Dazzling flame से जलने वाला substance, that is magnesium, and it will form the magnesium oxide. Must remember this point. Next is a brown colored substance changes into black in air. That will be copper, will form copper oxide. By passing hydrogen gas in this copper oxide, it will further get reduced and form copper and water. So the oxidation of copper in the first reaction and the reduction of the copper in the second reaction. Addition of oxygen is oxidation and removal of oxygen is reduction, or sometimes addition of hydrogen is also reduction. Along with these points, you must remember the oxidant and reductant. Oxidant and reductant. Oxidant is the compiled word of oxidizing agent. थोड़ा बड़ा था इसलिए हमने इसको शॉर्ट किया है. Oxidizing agent is oxidant which helps in oxidation, and इनका खुद का क्या हो जाता है, reduction. And reductant, reverse of the upper one. Reducing agent which helps in reduction and itself get oxidized. Hope so it will be cleared. So these are the main points we have covered from chapter 1. Now moving towards the next chapter, that is acids, bases and salt. First is the acid. Concept of acid is they are sure in test. They have H plus ions in the solution. Some acids like hydrochloric acid, nitric acid and sulfuric acid. Sulfuric acid is the king of acids. Must remember the point. King of the acids is sulfuric acid. And then phosphoric acid, H3PO4. This is weak acid. Now come to the point base. Base, they are bitter in taste, having OH negative ions in the solution. And then examples: strong base and weak base. Strong base are easily ionized in water and weak bases are partially ionized in water. Sodium hydroxide is strong, potassium hydroxide, ammonium hydroxide, NH4OH. Aluminium hydroxide. Name is simple, but you must remember the valency of the atoms to which the hydroxyl ions are attached. Otherwise, you will commit mistake regarding valency. So these are some examples of the bases: sodium hydroxide, potassium hydroxide, ammonium hydroxide, aluminium hydroxide. Now the term indicator. Indicators are the substances which are used to test the acidic and basic nature of the substance. How many types of indicators? Mainly natural and synthetic. Synthetic को आप artificial भी count कर सकते हो. Natural indicators are litmus, China rose, turmeric, and some other plants like petunia, geranium. And litmus is a purple dye which can be obtained from the plant lichen. Lichen is a symbiotic association of algae and fungus. Algae and fungus are the two different types of the plant kingdom. Algae comes from the Thallophyta. Thallophyta is a plant kingdom in which root, stem, leaves are not differentiated. They have the thallus-like structure. So the lichen is the natural indicator that is obtained from the plant lichen, and lichen is a symbiotic association of algae and fungus. Algae is green in color and fungus is the saprophytic plants. And China rose is the second one. Turmeric is the next one. That is also the natural indicator that can be obtained from the plants. Now if we talk about the synthetic indicator includes phenolphthalein, methyl orange and methyl red. Methyl orange and methyl red. Methyl orange and methyl red. Next point is regarding the properties of acid. Acid turns blue litmus into red, but bases turns red litmus to blue. How will you remember? Base turns the litmus blue. Base blue. B for blue. And acid changes the litmus blue to red. So final is the red, not blue. So you can remember the change in color of the litmus paper from acid and base. Next is the indicator. What indicator? Olfactory indicator. Olfactory indicator is the indicator which is used to check the smell of the substance like vanilla, clove, onion. These are the substances which can be tested by their smells. Either they are acidic or basic. Next one is the universal indicator. Universal indicators are the indicators which resist their change in the pH. Which resist their change in the pH. And what is pH? pH is the negative logarithm of hydrogen ion concentration. It is a definition. What is pH scale? pH scale ranges from 0 to 14. 0 to 7 is acidic in nature and 7 to 14 is basic in nature. Gastric juice 1.2. This is the pH value of gastric juice. 7.4 pure blood. Distilled water 7. Sodium hydroxide is a strong base having 14 pH. Milk of magnesia 10. These are some examples of the pH with their values. So they can be asked sometimes with their pH values. Now what is the pH value of acid rain? Acid rain, it is less than 5.6. Name the acid which is present in ant sting. Ant sting, methanoic acid, as well as nettle sting. Nettle is a plant. Nettle sting, these ant sting and nettle sting can secrete methanoic acid, and they uses this chemical as a self-defense mechanism. So this can be the application of pH. Now some examples of acids present in the substances like vinegar, acetic acid. Formula of acetic acid is CH3COOH. Tomato, oxalic acid. Tamarind, tartaric acid. टी से टी याद रख सकते हैं आप. Tartaric acid. Curd, citric acid. Sorry, lactic acid. Curd contains lactic acid. Orange contains citric acid. Lemon contains citric acid. So these are the examples of some common acids in the various substances. Now some important chemical reactions of acid. First rule is, if acid reacts with metal, it will give rise to salt plus H2 gas. This H2 gas is released with pop sound. Must remember the point. Pop sound identifies the release of H2 gas, hydrogen gas. If there brisk effervescence, then it will be carbon dioxide. In any of the question, there will be the brisk effervescence in the statement of the question, then you will go with the carbon dioxide. Next rule, acid reacts with metal oxide, then salt plus water. This oxygen will combine with hydrogen to form water. Next point, if acid combines with metal carbonate or bicarbonate, then NaCl, CO2 and H2O. Salt plus water plus carbon dioxide. Next point, with metal bicarbonate, acid gives salt, carbon dioxide, hydrogen gives water. So no need of the balancing during the reaction of acid with the bicarbonate. Next question is, what will be the product? This is slaked lime or lime water. By passing carbon dioxide gas, this will give CaCO3 plus H2O. This can be a precipitation reaction because calcium carbonate will get precipitated and it is of white in color. And this calcium carbonate reacts with water and carbon dioxide. It will form calcium bicarbonate. HCO3 is bicarbonate and whole twice can be due to the valency of calcium is 2 positive. This calcium hydrogen carbonate is soluble in water, but calcium carbonate formed in previous reaction will not be soluble. So a confusion between quick lime, slaked lime and limestone. Limestone can be marble, chalk, and the formula CaCO3, calcium carbonate. Slaked lime or lime water, CaOH twice. Quick lime can be calcium oxide. Must remember these formula to avoid confusion. If metal react with base, it will give salt plus H2. Suppose zinc plus NaOH gives Na2ZnO2 along with H2 gas. This Na2ZnO2 is a sodium zincate. In the same way, if aluminium along with base, it will form sodium aluminate NaAlO2 along with H2. But the formula is something typical to remember. But if you learn it with the valencies, oxygen carry -2, so 2 oxygen carry whole positive, whole total 4 negative. So 3 plus on aluminium and 1 plus on sodium, so it will be balanced. Total 4 and total 4 on oxygen. Either they may be positive or negative. So the aluminium with base gives sodium aluminate with hydrogen gas. Zinc plus base gives sodium zincate. But an important question, aluminium forms oxide, that is Al2O3. You can balance the equation by heat and trial method. So there is an odd number of aluminium. You can add 2 Al2O3. So it will be 4 and 3 O2. But this Al2O3 is the oxide which is amphoteric. So there will be the types of oxides. Metal oxides are basic. Suppose MgO, CaO, Na2O, These all are the oxides of metal, and oxides of metals are basic, and non-metal oxides are acidic. Suppose carbon dioxide, sulfur dioxide. But carbon monoxide and nitrous oxide are not acidic, they are neutral oxides. They are neutral oxides. They are neutral oxides. And the example of amphoteric oxide. Amphoteric oxides are the oxides which shows the acidic and basic nature. But neutral oxides neither shows acidic nor basic in nature. So amphoteric oxide is Al2O3 and zinc oxide. Must remember these two examples. Most frequently asked question. You can put star mark. Next question is related to salt. Some important salt we are going to discuss. First one is sodium chloride. Second is bleaching powder. Formula is CaOCl2 calcium oxychloride. Sodium chloride is common salt or rock salt. One can be obtained from sea. Can be related to Dandi March or Gandhi Ji. Calcium oxychloride, bleaching powder. Bleaching powder can be prepared by passing Cl2 gas into slaked lime, CaCl2 with water. The product of this reaction can be these two. CaOH twice plus Cl2 gives CaOCl2 along with water. Next one is baking soda and washing soda. Baking Ba for bicarbonate, NaHCO3. It doesn't have water of crystallization. And what about washing soda? Sodium carbonate, Na2CO3, dot 10H2O. It has water of crystallization. Must remember the number 10 molecules of water. Next one is POP. POP is the calcium sulfate hemihydrate. And what about gypsum? It is also calcium sulfate bihydrate. It means water of crystallizations are 2 molecules of water along with calcium sulfate. And what is the preparation of POP? CaSO4 dot 2H2O. On heating, it will give calcium sulfate hemihydrate along with 1.5 water molecule. This will be gypsum and it will be POP, plaster of Paris. जहाँ भी आपको वाइट सब्सटेंस प्लास्टर से रिलेटेड, टॉय से रिलेटेड, स्टैचू से रिलेटेड कोई भी क्वेश्चन पूछा जाता है, देयर विल बी पीओपी और जिप्सम. इफ यू विल बी आस्क्ड with the removal of hardness of water या extraction of the removal of the germs from water, so there will be the bleaching powder. Or related to the bleaching of the clothes, paper, textile industries, so there will be bleaching powder. And if the question of the compounds in the preparation of borax, so there will be sodium carbonate. Carbonated ores जितने भी होते हैं, they will release a carbon dioxide with brisk effervescence that can be used in fire extinguishing. So there is a common method of preparation can be asked. Uses, particularly from uses, the question of the gas based question is frequently asked, and must remember the formula of all the salt. Now a simple question regarding chloralkali process. Chloralkali process is a process where brine solution is used, concentrated NaCl with water, it will give NaOH plus Cl2 and H2. इस chloralkali process से पूछे जाने वाले क्वेश्चन, what is the end product of this process? That is sodium hydroxide. It is caustic soda. Name the gases formed in chloralkali process, that is Cl2 and H2 gas. Well, what kind of solution is taken in chloralkali process? That is brine solution, that is concentrated NaCl, sodium chloride and water. And the gases which are deposited on electrodes, you must remember the electrode. Hydrogen is positive in nature, so it will be on negative electrode, and negative electrode will be cathode. And it is negative in nature, Cl negative, chlorine, so it will be on positive, and positive is anode here. Must remember these 2 points where hydrogen and chlorine gases are deposited on their respective electrode during chlor-alkali process. One of the important question, you can put star mark. Now what is alkali? Alkali is the aqueous solution of a base. Suppose you have NaOH is a base in aqueous solution, so you will get Na positive OH negative. If any substance that furnish OH negative ion is a base, so there is ionization of base. In the same way, HCl hydrochloric acid furnishes H plus ions along with chloride ions. So this will be the ionization of acid and base. Now what is royal water? Royal water is a mixture of HCl and HNO3, hydrochloric acid and nitric acid in the ratio 3:1. Must remember the ratio 3:1. Mostly confusion होता है कि आप इस ratio को opposite कर देते हो. So 3:1 ratio HCl or HNO3. What is the use of this royal water and the other name of this royal water? It is also called aquaresia, and it will be used in dissolving the metals which are used in making jewelries like gold, platinum. And the solution which is used for the cleaning of metals is the royal water or the aquaresia, that is a mixture of concentrated hydrochloric acid and sulfuric acid. Now the term alloy. Alloy is a mixture of 2 or more metals or non-metals. Metal and non-metal. Suppose zinc and copper, it will give brass. Copper and tin gives bronze. Solder is Pb, lead and tin. Alnico, aluminium, nickel, cobalt. And you can remember some other alloys also. Now properties of metals. They are sound producing, so sonorous in nature. They can be converted into thin wires, so that is ductility, the ability of the metals to be converted into thin wires. If they are converted into thin sheets, it is malleability. Examples of metal. You will get a zigzag line in periodic table. Left of the periodic table is almost metals and right of the periodic table is non-metal. And to this zigzag line, the borderline elements are the metalloids, which are having characteristics of both metal and non-metals. So a MCQ will be asked from this point. Suppose you have zinc, aluminium, carbon and calcium. Which among the following is a non-metal? So answer will be carbon. These all are metals. Next point, full form of PVC. It is polyvinyl chloride. Next point is most lustrous non-metal, that is iodine. Allotropes of carbon: diamond, graphite, fullerene. Which among the following is good conductor? That is diamond. No, it is graphite. Which one is thermally stable? It is graphite. Which one is hard? Diamond. Which is used for glass cutting? Diamond. Which is having free electron? Graphite. Which uses all the 4 electrons? Diamond. The allotropes which has only 1 free electron? Graphite. Which one is having layered structure? Graphite. Which one is soft? Graphite. Which one is hard? Diamond. Which one is insulator? Diamond. And fullerene is concept of fullerene is given by Buckminster Fullerene. So all these questions will be asked from this point. Now next point is name the metal which are soft that can be easily cut with knife. Lithium, sodium, potassium. Name the metals which can be melted on putting in your palm. That will be cesium and gallium. Good conductor of heat and electricity, silver. Bad conductor of electricity, mercury. Metal which is liquid at room temperature, mercury. Non-metal which is liquid at room temperature, bromine. Now what is ionic compound? There is a transfer of electron from one species to the another. Suppose NaCl is an ionic compound. How will you prepare the ionic compound? So there will be 4 steps minimum. First, electronic configuration 281, chlorine 287. So second point, represent dots of valence electron. 1 is there, 7 is there. So there is a transfer of electron. Na gives Na positive plus electron. There is a loss of electron, oxidation takes place. And Cl gain electron to be Cl negative, because there is a requirement of 1 electron to be stable to complete their octet. And after losing 1 electron, it will be stable to complete their octet. So the formation of sodium positive and chlorine negative ions, after formation, there is the electrostatic force of attraction between these oppositely charged ions to form ionic compound. So you can practice the MgO, MgCl2, CaCl2 and HCl. And must remember this HCl is covalent as well as ionic. So what is covalent compound? There is a mutual sharing of the electrons, or there is a mutual sharing of valence electrons to complete their octet and form the bond, that is covalent bond. What are the properties of ionic compounds? They are hard. They have high melting and boiling point. They are brittle. They conduct electricity in molten state, not in solid state. A point to be asked here. Ionic compounds conduct electricity only in molten state, not in the solid state. So you must practice the formation of ionic compound. Next is metallurgy. There is the extraction of metal from the earth crust, from the minerals that is obtained from the earth crust. What is mineral? Naturally occurring substance that can be obtained from the earth crust. What is ore? After removing the impurities from mineral, we get the substance including metal with traces of impurities. And what are the impurities? That is gangue. So these are the extra impurities present in the mineral that is to be removed to get pure metal. How the active metals can be purified? It will be by electrolysis or electrolytic method. Name the inert metals, lowermost metals in the reactivity series, like silver, gold, lead. These are the metals which are present in their native state. How the more reactive metals can be extracted, like sodium, potassium, aluminium. They can be extracted from electrolysis. Point to remember, the metals which are extracted by electrolysis. What is calcination? Calcination is the process of extraction of metals in which a carbonated ore can be heated to form metal oxide along with the volatile impurities. Volatile impurities can be escape out in the atmosphere in the form of gases. And what about roasting? Roasting is the formation of metal oxide of sulfide ore in the presence of oxygen. So here zinc oxide is formed along with volatile impurities, sulfur dioxide. So the formation of metal oxide in both the cases, in case of roasting and calcination, but roasting includes sulfide ore and calcination includes carbonated ore. Must remember the reaction. Now coming towards the carbon compound. Carbon, atomic number 4, Atomic number 6. Valence electrons 4. Valency is 4 plus minus 4, you can say. Valence electron 4. So carbon can be represented by 4 dots. It is tetravalent. It shows catenation. What is catenation? Catenation is the self-linking property. Self-linking property of the element to form a long chain is called catenation. Suppose we have a carbon, another carbon, then another carbon, and valency of these carbon atoms are satisfied with hydrogen atom. So this is a electron dot structure. Hydrogen atom carry single electron, that is to be used in the formation of a covalent bond. So carbon is tetravalent. It will form the 4 covalent bond. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So there is the mutual sharing of electrons. Mutual sharing of electrons to form the covalent bond. Here the formula is C4, 1, 2, 3, 4 and H10. This is butane. C4H10 is butane. This is a hydrocarbon. And hydrocarbons are the compounds in which carbon and hydrogen atoms are formed, present. Or we can say the compounds of carbon and hydrogen are called hydrocarbons. So what are the types of hydrocarbons? There are 2 types of hydrocarbons, saturated and unsaturated. Saturated alkane, unsaturated alkene and alkyne. Alkane have CnH2n plus 2. Alkene CnH2n, general formula. Alkyne CnH2n minus 2. Suppose you are asked pentene. Then what is the formula? C5H10. If question will be pentyne, so you must follow CnH2n minus 2. Then C5H8. Okay. Now functional group. Any atom or group of atoms which can change their chemical properties. Functional groups are halogen, like chlorine, bromine, iodine, fluorine. Aldehyde, CHO. Alcohol, carboxylic acid, suffix is oic acid. Al suffix for aldehyde and ol is for alcohol. And next one is ketone. Ketone, ONE is used for ketone. Ketone is central functional group, but aldehyde is terminal. Alcohol is terminal as well as central. Carboxylic acid can be used as terminal functional group. टर्मिनल यानी जो चेन के हाइड्रोकार्बन चेन के एंड पे प्रेजेंट होता है. सपोज ब्रोमो ब्यूटेन. ड्रॉ द स्ट्रक्चर. So must draw the carbon atom 4 for butane, and bromobutane, it means one bromine atom is on the carbon atom. If position is not mentioned, you can draw it anywhere, and rest of the positions are balanced by hydrogen. This is bromobutane. So you can write CH3, CH2, 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 Br. What is homologous series? A series of compound having same functional group which is differ only by CH2 unit or 14 unit mass is called homologous series. Example, prepare a homologous series of ethanol, C2H5OH, C3H7OH, and one more member you can draw. If you will be asked up to 5 members, you can draw easily by differentiating with only CH2 group. And this CH2 group is having 14 unit mass. 14 in the sense carbon atom, mass number 12, and CH2, it means 1 hydrogen atom. Mass number of hydrogen is 1 and 2 into 1 is 2. So 12 plus 2 is 4, 14. So there will be 14 unit mass difference in the homologous series. Next point is related to isomerism. If the molecular formula is same but structures are different, molecular formula is the compounds having same molecular formula but different structures, shows isomerism. Draw the structure of pentane. So simply N-pentane, all the valencies are satisfied by hydrogen. Formula of pentane C5H12. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it will be okay. Second, this is neopentane. CH3, 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 CH3. Next, 4 carbon atom, 1 with branching. So CH3, CH2, CH, CH3, CH3. 1, 2, 3 and 4th valency is satisfied by hydrogen atom. So these are the isomers. This is isopentane. So these are the isomers you can draw easily as asked, as per the number of carbon atoms, as alkene, alkene, alkyne. Alkene or alkyne, there will be double bond. Alkyne, there will be triple bond. Simplest alkene, CH2 double bond, CH2, that is ethene, and simplest alkyne, C2H2, or you can write CH triple bond CH. This is acetylene or ethyne. Now the question will be asked from here. The compounds which undergoes addition reaction from hydrocarbon is unsaturated. Unsaturated in the sense having double or triple bond. And the compounds undergo substitution reaction are saturated compounds. Saturated compounds containing carbon-carbon single bond. Single bond. Carbon-carbon single bond. Suppose you are given C2H6, CH4, C2H2, C2H4. Which one is showing addition reaction? So this is alkane, this is alkane, alkene, alkene. This is alkyne. So alkyne and alkene are unsaturated. They can show addition reaction. And ethane and methane, these are saturated. They can show substitution reaction. Remember this point. Next question is, what is micelle? There is a long chain of fatty acids containing polar part, like, what is the formula of soap? C17H35COO negative Na positive. What is the structure of soap? This will be non-polar part, this is polar part. This is tail, this is head. Tail is hydrophobic, head is hydrophilic. This is hydrophobic. This is tail. How will you arrange the micelles? Suppose this is a drop of water. So outside the water in this container. So polar part arrange outside. And the non-polar part inside. The polar part dissolves in water and non-polar part dissolves grease. and after some time the dust will be washed away. What is the arrangement of soap in water? Suppose this is a container having water, so this is polar part and this will be the tail. This is the arrangement. Suppose if you have this dust, oily substance on the cloth, so the polar part outside and chain inside, water is there. So this will be the arrangement of the soap in water, on cloth, and micelle formation, formula of soap. What is the difference between soap and detergent? Detergent can work in hard water, but soap can work only in soft water. What is the difference in the formula of soap and detergent? Soap contains the salt of sodium and potassium, and detergent contains the salts of ammonium ion. So this is all about the micelle formation. Now the type of reactions of hydrocarbon or carbon compounds. So mainly 4 reaction. Addition reaction we have discussed. Addition reactions for unsaturated compound. Second is substitution reaction for saturated. Suppose you have CH4 plus Cl2, it will give CH3 Cl plus HCl. And what about addition? Addition reaction, it means CH2 double bond CH2 gives CH3 CH3. And this is reduction also, addition of hydrogen. This reduction takes place in the presence of nickel, palladium, platinum. This is also called catalytic reduction. Next is combustion. If you have CH4 along with oxygen, then there will be carbon dioxide and water. End product of the combustion reaction is carbon dioxide and water. Suppose you are given C2H6 plus O2 gives CO2 plus water. We can balance the equation, but the combustion reaction gives the product carbon dioxide and water. Next reaction is oxidation. Here we are talking about the oxidation of hydrocarbon and the carbon compound. Suppose we have ethanol C2H5OH. It will form CH3COOH. It is directly oxidized in the presence of strong oxidizing agent. And what are oxidizing agent? That is KMnO4. And second one is K2Cr2O7. Must remember these two oxidizing agent as oxidation. So these are the 4 reactions: addition, substitution, oxidation and reduction. Industrial application of the reduction is conversion of vegetable oil into ghee. The same reaction of the changes of ethene to ethane by addition of H2. You can cite the equation in this application. Next is esterification. Esterification is the process in which alcohol C2H5OH combines with acetic acid CH3COOH gives ester C2H5COOCH3 along with water. This is ester. Esters are the sweet smelling substances. Sweet smelling substances. Esters are the sweet smelling substances. Most of the time question पूछा जाता है कि sweet smell any substance which is sweet smelling substance, name the compound which is sweet smelling in nature that can be prepared with the acid and alcohol. So एग्जाम्पलर क्वेश्चन आपको ऐसा मिल जाएगा जो कि मोस्ट फ्रिक्वेंटली वहाँ से एज इट इज़ आपको क्वेश्चन बोर्ड में देखने को मिल सकता है. So there is a rearrangement in the sentences only, not a big deal. So you must remember the reaction. Main point is sweet smelling. Reagent or the substrate, that is, or you can say reactants ethanol and acetic acid, and ester is formed along with water, along with the elimination of water. This is esterification. One more point is related to the change in color with the synthetic indicators like phenolphthalein. Phenolphthalein in acidic medium, colorless, but in basic medium, it will be pink. In the same way, you will have to remember regarding methyl orange and methyl red. Methyl orange and methyl red. सो ऑलमोस्ट हमने इम्पोर्टेंट पॉइंट्स कवर करने की कोशिश की है, जो कि आप एक बार फ्रीक्वेंटली वीडियो को स्पीड अप करके देखेंगे तो भी आपको बेनिफिट होगा. सो श्योरली बेस्ट विशेस विद यू ऑल एंड गुड लक टू एवरीवन.